So following on from some of the earlier videos, we got to this stage here where we were trying to understand this function here using the second fundamental theorem of calculus. We would then get to this, and when we try and analyze this, we came up with this this graph. From this graph, we then came up with our original function, and it looks something like this. Okay, so so when you come to read this, when you read this, this is saying the area from 0 to x of this graph here. So let's just say this here is at a at a point A. So up here is also A. Well, when you come to read this, you've got to read it as the area from 0 to x. So from 0 to x of the derivative of this graph here. So when you come to read this, the height of this thing here is the area from 0 to x of this graph here. Okay, so when you come to read this, the height of this, which is the height of this, is the area from 0 to a, from 0 to a here. So basically the height of this here is the area from 0 to a, is this area here. Is this area here. Okay, from 0 to a. So the height of this thing here is the area from 0 to a. So the height of this, which is this bit, is the area from 0 to a in our case here. Now when you let's say this here is minus a now. So this here is minus a. So so the location here minus a. Well, when you come to interpret this, it is the height of this thing. The height of this thing here is the area from 0 to minus a. Okay, so in this case, for this to make sense, we would switch these two around. So we would switch these two around. So it would be from minus a to 0, but then there's a property that says that whenever you switch these two around, you've got to stick a minus in here. So then therefore this here will give us a positive area because it's from minus a to 0. But then you've got a negative here, making the whole thing negative. Okay, so when you come to read this, read it. When you come to read this, read it as from 0 to a. So it's really the area for a here, and then in the case of a being negative, it still makes sense. It is you evaluating it from 0 to minus a. But then when you come to switch these two around, it is really the integral from minus a to 0 here. That will then give you this area. But then because you switch these two around, you've got to have a negative in front of it. Okay, so this and something else. The limit here, the height here, can be interpreted as the area from 0 to infinity as x heads towards infinity. So the limit here, this asymptote here, is really the area from 0 to infinity. So it's really the whole the height here. The height here is really the area from 0 all the way to infinity here. So that's this yeah. So the height here, when you come to read it, it is the area from 0 to infinity, and then this negative height here is really the area here from 0 to minus infinity. Okay, and this limit here happens to be root pi over 2. It's not so obvious, but it is that, and it's quite strange how pi managed to creep itself in here. But we will look at this another time. Okay, just so looking at the whole point of this video is that when you come to read this here, read it as an area. So read it as the height of this being the area down here. Okay. Yeah. Okay.